In 1967, at Columbia University, Einstein's mission to challenge quantum mechanics was taken up by an unlikely recruit. John Clauser was on the verge of earning a PhD in astrophysics. The only thing standing in his way was his grade in quantum mechanics.
When I was still a graduate student, try as I might, I could not understand quantum mechanics.
Clauser was wondering if Einstein might be right when he made a life-altering discovery. It was an obscure paper by a little-known Irish physicist named John Bell. Amazingly, Bell seemed to have found a way to break the deadlock between Einstein and Bohr and show once and for all who was right about the universe.
I was convinced that the quantum mechanical view was probably wrong.
Reading the paper, Clauser saw that Bell had discovered how to tell if entangled particles were really communicating through spooky action, like matching spinning wheels, or if there was nothing spooky at all, and the particles were already set in their ways, like a pair of gloves. What's more, with some clever mathematics, Bell showed that if spooky action were not at work, then quantum mechanics wasn't merely incomplete, as Einstein thought. It was wrong.
I came to the conclusion that, my God, this is one of the most profound results I've ever seen.
Bell was a theorist, but his paper showed that the question could be decided if you could build a machine that created and compared many pairs of entangled particles.
Bell turned the question into an experimental question.
It wasn't just going to be about philosophy or trading pieces of paper.
And the experiment that he envisioned could be done.
You could really set up an actual experiment to force the issue.
Clauser set about constructing a machine that would finally settle the debate.
Now, I was just this punk graduate student at the time. This really seemed like, wow. There's always the slim chance that you will find a result that will shake the world.
Clauser's machine could measure thousands of pairs of entangled particles and compare their spins in many different directions. As the results started coming in, Clauser was surprised and not happy.
I kept asking myself, what have I done wrong? What mistakes have I made in this?
Clauser repeated his experiments, and soon French physicist Alain Aspect developed a more sophisticated test. With significantly more definitive results, Aspect removed virtually all lingering doubt. Clauser's and Aspect's results are truly shocking. They prove that the math of quantum mechanics is right. Entanglement is real. Quantum particles can be linked across space. Measuring one thing can, in fact, instantly affect its distant partner, as if the space between them didn't even exist. The one thing that Einstein thought was impossible, spooky action at a distance, actually happens.